So we have a triangle ABC and we need to show that C times A cosine B minus B cosine A equals A squared minus B squared. So we will start from the left hand side, but before that let's specify the law of cosines. So if we have a triangle ABC whose sides are given by ABC represented by lowercase letters, then cosine of A is given by B squared plus C squared minus A squared over 2BC. Similarly, we can define cosine B and cosine C. Now let's come to our problem. So we'll start from the left hand side. Here we are given C times A cosine B minus B is B times cosine A. We're going to multiply each term within the parentheses, but see, we have CA multiplied to cosine B minus CB multiplied to cosine A. Now we're going to use the value of cosine B. So cosine B, that's given by C squared plus A squared minus B squared divided by 2CA minus CB multiplied to cosine A. So we're going to use the value of cosine A, that's B squared plus C squared minus A squared divided by 2BC. So we're going to cancel out CA from the numerator and the denominator. Similarly, we can factor out CB from the numerator and the denominator. We're going to take half as the common factor. We are left with C squared plus A squared minus B squared minus B squared minus C squared plus A squared. So here we have positive C squared and negative C squared cancelling out, and within the parentheses we have 2 times A squared minus 2 times B squared. So if we factor out 2, we're going to get A squared minus B squared. So this is the expression on the right hand side. Hence we have successfully showed that the given trigonometric equation is true. Hence proof.